course-provided software, realize this is a nice local development option as well. And it similarly lets you configure most anything you would like. Any questions then? All right, that feels like a good point to take a 5-minute break. And when we return, why don't we dive into PHP and actually finishing the back end of something like Google.com. So let's take 5. All right, we're back. So just a couple of details. You should have or should soon receive an email invitation from the course's discussion tool. We'll post a link and an announcement on the course's homepage to explain where to go and how to go if you did not receive such a link, but it would have gone to this email to the email address with which you registered for the course, FYI, in case that's not an address you use quite commonly. But again, more details on the course's homepage by tomorrow. And let me introduce another of the course's TFs, Alan, who, if you wouldn't mind coming up close to my microphone, if you'd like to say hello to the class.
Hi, everyone. My name is Alan. You can call me Alan. It's easier for you. And I'm here to take your questions, help you out with anything you need.
OK, excellent. Thanks. And Peter, who you met on Monday, will be back shortly this evening. And once the lecture wraps, we'll dive into section, which, again, will be an opportunity for slightly more intimate Q&A to go over concepts that might be a little more abstract. And particularly once the first project is released, which will be on July 9th, is when the first one will go out. It'll be an opportunity particularly to focus on the project and get direction and guidance and design tips on those. So more on that to come. All right. So time for some PHP. So recall that we talked briefly about some of the basic UI mechanisms that browsers allow. Radio buttons, text fields, text areas, checkboxes, and the like. And these really are going to be the fundamental mechanisms whereby we go from static websites with just HTML and CSS to dynamic websites with some kind of server-side intelligence that does something based on user input to produce dynamic user output. So these days, thankfully, the web's getting more interesting and sexier than some of these more old school UI mechanisms, but even the fanciest of autocomplete widgets that you see and calendaring things where you can choose calendar dates and the like are still built on top of these, but all the more stylized these days with JavaScript and with CSS. And so we'll look at some of that fancier use of input mechanisms in a few weeks when we get to Ajax and JavaScript itself. So here is a representative snippet of Google. Recall that on Monday we started implementing the same interface, even though it was all black and white in text. But we did have a text box, and we did have a couple of buttons. And when you click that submit button, you actually ended up initially nowhere. Right? We ended up on my same file, which was not dynamic at all. But then I went in and changed the action attribute so that we actually submitted to Google. So technically, we cut some corners and didn't implement a dynamic website ourselves. But we did look at the basic mechanism whereby form input becomes GET requests. Or an alternative to GET is POST. For those familiar, what is one or more of the fundamental differences between using GET, capital G-E-T, versus POST, P-O-S-T? Yeah.
Well, GET's actually going to include what you entered in your form in the URL.
OK.
And POST is just not going to do that.
OK, excellent. So GET requests will have state change in the URL itself. And that's exactly what we saw on Monday with Google, where we had question mark. And what came next? Question mark, Q equals whatever, Harvard, whatever I happen to type in or the user types in. So POST does not do that. So that's a nice distinction. But what are some more distinctions? Or what would motivate you using GET versus POST if functionally they could be the same? You could still get search results, for instance, even though Google, as an aside, does not support POST. What else should drive you to GET versus POST? Or vice versa? Yeah.
Well, if you're on a site that tends to deal with uploads, you're going to want to use POST because it has special ways to deal with large files.
Excellent. Yeah, so GET requests are not so great for things like file uploads, photo uploads, right? If anything, conceptually, this just makes no sense. How do you upload a file in a URL? Now, technically, you can encode it using something called base64 encoding, where you convert the binary image of zeros and ones to A's and B's and C's and 1, 2, 3s and so forth. But the other gotcha is that most browsers have a length on the maximum length of the URL. Unfortunately, this is not standardized, and it's barely even documented. But the rough rule of thumb is if your URL is several hundred characters long, it's probably too long. And a reasonable cutoff is something like 1,024 characters. You're definitely pushing your limits. However, it's completely browser dependent. Some browsers support 8,000 character URLs, 1,000 character URLs. But the takeaway is that really you have to deal with the lowest common denominator, whatever that is. And so anytime your URLs start getting long, it's probably time to rethink your design and start using something called Ajax, which again we'll look at. or using post. Post does not have a limit. In fact, one of the upsides of post is that it, in the HTTP headers, will tell the server how big the file or parameters are that are being posted, so to speak, so that the browser knows when it's received everything. So the browser figures out, OK, this is like a 5 megabyte photo, so I'm going to tell the web server through the headers, expect 5 megabytes. And then what the server gets is below all the headers is all of the crazy zeros and ones, or equivalently A's, B's, C's, 1, 2, 3's, but it knows where they stop. So it knows when it's received the whole photo. So post is great for that. What else is post compelling for? What other use cases besides file uploads? Again, put on your paranoid hat. If you're using get, what are you at risk for instance? Yeah?
Somebody actually sniffing what the user sends.
Perfect. So and what might the user send that could be sensitive?
I mean, you wouldn't really send a password or a
Good.
username with a get request.
OK, good. So sending usernames, passwords, credit card numbers, anything that's arguably sensible probably should not be submitted via get because it ends up in the URL. And why is that bad? Well, fundamentally, it's still being sent to the web server. And if it's over SSL, it's at least encrypted. However, it's not encrypted from your family members or your friends or your roommates who might sit down at your same computer. And you know what you can do with most browsers today is browse through the history, right? And if it's in the URL, that means it's going to get logged. And it's going to end up in autocomplete until the cache is manually cleared. It's just too easy then for someone to find it. And it's also going to end up somewhere else. Even though it might be transmitted over SSL, so random people on the internet or Starbucks can't see it, once the server gets the request, many servers, as you can maybe infer from the http.conf configuration file earlier, have logs. And what tends to get logged in logs? Not posts, because they could be huge, 5 megabytes and whatnot, but typically what are logged in logs? GET requests, including the URL that was visited, which means any website that's ever used GET for password authentication or credit card submission, which would be rare, but could happen, especially if the person doesn't know what they're doing, it's ending up in the logs, which means some random person's unencrypted log files has all of your sensitive information. So in short, anytime something is big or anytime something's sensitive, GET is not the way to go. However, that would seem to suggest, fine, just use post all the time, right? Just avoid all these issues together. I don't have to remember what the difference is. But what's the downside of using post? Based on your own, maybe even non-technical user experience. What's a downside? Yeah.
Can't copy-paste the URL.
Yeah. Perfect. You can't copy-paste the URL. Completely reasonable concern, especially from a user experience perspective, because very reasonable for someone to want to copy the URL, say, oh, check out this book, or check out this link, whatever it is you're looking at. And it's actually pretty infuriating when the person who receives the email says, oh, I only see their home page, because they've just redirected them because of a number of things. One, the state that was necessary to remember that book, the ISBN or whatever, was not in the URL because they were using post. Or it's even worse, some websites, even I think the Harvard Coop does this, when you navigate around their website, the URL similarly doesn't change because the information is being stored, as best I can tell, in their session cookie, something we'll talk about next week or later tonight, whereby it's only remembered by the server thanks to a cookie where you are, which means even you can't bookmark your own pages that are of interest to you. So in short, horrible design. And some websites are very much guilty of this. So anytime you want the user to be able to save state in a URL, rather in an email, or just with the back button too, it's helpful to make sure it is in the URL itself. Of course, there's another reason. This is getting better these days with modern browsers, but typically with posts, if you click reload, you'll often get prompted. And the website will say, or the browser will say, are you sure you want to resubmit this form? So there's also issues of resubmitting forms and whatnot that are typically bad. And so one of the things that's gotten more common these days to avoid people accidentally checking out twice or buying things twice on an online store and having that message say, wait a minute, are you sure you want to submit this form? What you can often do is once the user does a post because they've uploaded something or they've bought something, what you then do is immediately redirect them with a 301 or a 302, which only use gets. You can't use redirects to repost somewhere else, FYI. Then the user, if they accidentally hit reload or hit back in their browser, they're only going to go back and forth between a GET request, not a post. So you can also discourage the user from submitting a form again. And there's other protections you can put in place, but that's another reason too. If you want to avoid resubmission of forms, sending a GET via redirect can be one level of protection against that. All right. So here we go with PHP. This is going to be a fairly rapid tour of this because, again, the course does assume non-trivial prior programming experience. So this is another detail, too, where if you find yourself, what is programming? Again, we should have a conversation right after class or with Alon or with Peter if you're more comfortable about what your own background is, because we're going to start talking about things like arrays and hash tables and associative arrays. And if this is all new to you, it's definitely going to be a bigger challenge, but we've certainly had students do it before, so use your judgment along the way. So one of the best things about PHP is its documentation, to be honest. It's actually fairly user-friendly, very nice to navigate. And so let me just pull up an arbitrary example of kind of a boring function, but one that's commonly used. If I Google PHP date function, I can go up to a representative documentation page here. And just to give you a quick tour of something you'll see much more when you dive into the course's projects, along the left-hand side of the website is a list of all of the related or available functions. PHP is actually not this slow of a language usually. Let's try reloading. OK, I cheated. So actually, there's an interesting lesson there. So actually, let's try this rather than just give up on this altogether. Let me see if we can. Oh, damn, now it worked. So I was going to pull up Chrome's network tab. We could look at exactly what was hanging there, but it seems to have resolved itself. So quick tour then of the page here. So on the left-hand side is all of the related functions, just FYI. A little overwhelming at first, but the reality is for this class, and really in general, you're not going to need to know every one of these functions. Just looking it up on demand is useful enough typically. On the right-hand side is the canonical layout of a function. So it tells you first what version of PHP supports this function. This is actually important. Not so much when you control your own server, because odds are you'll be running yourself if it's your own server. Pretty recent version of PHP, 5.1, 5.2, 5.3, 5.4 are fairly recent incarnations, with 5.4 the latest. But there are some web hosting companies that might still be running PHP 4. Not terribly common, but you will lose a huge amount of functionality, including object-oriented programming support, if you are on something as old as PHP 4, just FYI. So what does this function do? It formats a local date and time, which means if I give it a string like h:(m) for hours: minutes, or something like that, it should return to me a formatted string like 3:00 p.m. or something like that. So that's what it does. It gives me the current time, or converts a numeric timestamp to a date. So here's how you parse the signatures. This means it returns a string. This means it takes a string as its first argument, which is the format. Any variable in PHP, as we'll see quite a bit, starts with a $sign. Square brackets in documentation means it's optional, which means if you want to override the current date and time, you can pass in a numeric timestamp. For those unfamiliar, a timestamp in many programming languages is the number of seconds since January 1st, 1970, the so-called epoch, and then you can override the default behavior. Useful if you've stored timestamps in like a database and you want to display them in some human-friendly way after the fact. All right, this returns a string formatted according to given format string, ... Here's just some more detail on the format. So the format parameter can apparently be a quoted string containing all of these various placeholders, D for day, J for day of the month without leading zeros, and so forth. Memorizing this is not a good use of any human's time, but looking it up is reasonable. Let's just scroll down past all of that. Timestamp does what I promised. Return value returns a formatted date string. If you do something wrong, it goes on to explain that there's an error. And then let me scroll down here. The examples, frankly, is where my eye is typically drawn most immediately. So if I take a look here, this gives me some little cheat sheets. If I want to print out echo date, quote unquote, L, for whatever reason, L denotes the day of the week. If it is Monday, it would print Monday. Today, it would print Wednesday dynamically. Here's a more complicated date string that they claim will print out this, and so on and so forth. This is the kind of thing that this function does. But the takeaways for our purposes now is just PHP's documentation is always structured in this way. Summary of the function up top, description of the parameters, some version notes in case you need to be aware what version of PHP you have, example 1, example 2, example 3, and then at the bottom, there's generally some pretty intelligent discussion on the comment threads that are there. It's not really crazy talk. They seem to moderate it quite well. So you actually see people sharing useful code for common workarounds or common tricks that someone might want to do related to the date function. So in short, the documentation will be your friend. And what we will do in lecture is not go through mind-numbing tours of the various functions that exist and so forth, but focus much more so on the concepts, on the syntax, and on the overall framework so that you know as you dive into how do I do this, where it fits in big picture in terms of a project. So PHP is an interpreted language. What does it mean for a language to be interpreted? Or what is the opposite of an interpreted language, even though they're not truly, literally opposites? Yeah? A compiled language. So a compiled language is something like C or C++ or language that has source code written in English-like syntax, but you have to run it through a compiler like GCC or Visual Studio or the like, and it outputs what's generally called object code, or more specifically zeros and ones that are patterned in a way that a CPU, like an Intel CPU, understands. An interpreted language skips that step, essentially, whereby instead you write the source code, and then you pass your source code through what's called an interpreter instead of a compiler, and an interpreter essentially reads that language that you've written, the source code you've written, top to bottom, left to right, doing line by line exactly what you tell it to do. So the upside is there's no intermediate step. You don't have to run the compiler, then run your program. In an interpreted world, you just run your program through the interpreter, and it's that. It's one step instead of two. But what's a downside of the fact that it's interpreting it line by line as opposed to converting it to zeros and ones? Performance, typically. So compiled languages tend to be faster because you're spending more time in memory and disk space up front to convert source code to object code, zeros and ones. But once it's zeros and ones, it's super ready to be read and understood by the CPU. Whereas an interpreted language typically needs to be literally interpreted again and again. And every time I call the date function, date needs to be parsed or read and then converted effectively to the underlying functionality. Now, there exist compilers of sorts for PHP and for other interpreted languages and what are called opcode caches. More on this at the end of the semester when we talk about scalability, which simply means for now that smart web servers and interpreters will do the interpretation once, convert it to some intermediate format, and then save that intermediate format, which in the PHP world is called opcodes, O-P-C-O-D-E-S. And this just means it will skip that step the next time around. It's not quite compiled, but at least it's better, it's a closer approximation to it. Frankly, it's a nice thing with interpreted languages because you don't have to go through that annoying step of recompiling every time you make a change. You can interact with your code a lot more fluidly. It just saves some steps, especially for large projects, which might have large numbers of files and lines of code to actually compile otherwise. So some upsides and some downsides. If you're crazy popular, like someone like Facebook, Facebook actually has a framework called HPHP, which they released open source a while back, which actually compiles PHP down to C++, which is then compiled in turn to object code to get maximal performance out of the code that they write. And this is motivated by a number of things, but among the things they discuss publicly is this way, PHP is fairly omnipresent. It's a fairly easy language for people to learn, especially coming out of college and the like. So it means they can have their developers using a language that's fairly easy to learn. They probably already know it, and they can then defer the performance details that are typically associated with a language to some of their more advanced engineers who can then take PHP code down to something that's even more highly performing. So among the options that exist these days. So a lot of the arguments you might see on the web about performance of PHP versus Ruby versus Python versus Java versus this, there are many, many different technical solutions to the performance question, and a very valid heuristic, I think, when choosing a language, whether it's going to be PHP or another, is what you already know and what the cost is to you, the developer, to learning something else, what your friends know or what your colleagues know, and also what tools exist to mitigate any of the prices you pay to use something like an interpreted language. So SUPHP, this is something that will be installed in the CS50 appliance. It is installed on some web hosts, but not nearly as many as would be good. So SUPHP is substitute user PHP, and it exists to solve the following problem. When you have a web server, you have software running on it that listens for connections on port 80 and so forth. Years ago, most such servers ran as a username called root. Root is the administrative user, and running anything as root is generally bad. Why? Yeah.
Well, you can destroy your computer.
You can destroy your computer. How? Be more specific.
Well, you can remove files that are essential to the operating system.
good. So if the root user has full-fledged access to the system, if you make a mistake in your code, if it's a web server and you're running web code, and you make a mistake and you accidentally delete the wrong directory, that is permanent. Like you can touch anything on the system, including the password file, which even though it's encrypted, should not generally be shared with the world. So in short, running anything as root puts you at risk because if what root is doing is buggy, and odds are you're a human, you err, you're going to write buggy code sometimes. That means who's running the buggy code? The most important user on the system, which means your entire machine could be compromised if you screw up. So finally, the world years ago got into the habit of at least running web servers in particular as different usernames. Sometimes nobody, literally, the username nobody, or www, or Apache, or HTTPD. Doesn't really matter what it is. It matters that it's not root. But some problems arise, especially in this popular world these days of vhosting and web hosts, commercial web hosts. Because think of this. If you are customer A and there's a customer B, and you have someone like DreamHost or the like, you each have accounts with them, and you have your own usernames and passwords, and you have your own home directory, so to speak, where you can store your code. But the web server runs under username Apache, for instance. Apache, again, being the web server software. In terms of permissions, Apache is not you, obviously, because you are A or you are B, so you have different usernames. But if Apache is the web server, and the web server needs to obviously be able to see your files in order to serve them up, what kinds of permissions do your files need, if you're familiar with Linux file permissions, or Windows, or really file permissions in general? Your files have to be what's called world readable, typically. You can do more fine-grained permissions, but the reality is on most systems, the easier approach is you're told to chmod your file 644. More on that in the future. But make your files world readable. Why? Because you don't really need the world to read them. You need the web server to be able to read them, including especially your PHP code, which we're about to start writing. So what's the implication, though? There's a few things. If your files are world readable so that this middleman, Apache, can read them, that's great. Makes the website work. But it also means that someone else can read your files. Who?
That would probably be the other customer.
The other customer, customer B, right? Because world readable is world readable. Now, if your files are being served up on a web server, that means you can see your files at URLs, like /hello.php. So that means anyone on the internet knows what your files are called. So the other customer, because he or she can log into the same server, can just enter your directory, and even though they might not be able to see all of your files, if they know what they're called, they can then definitely see your files by just using a text editor or some kind of program that just opens these files. Now, that's not such a big deal for JavaScript, for CSS, because frankly, who cares? That stuff is by nature of JavaScript and CSS going to be sent to the browser and the whole world anyway. And you might try to obfuscate it, as we'll discuss in a few weeks, with minification and hiding things from users. But you can't really protect your intellectual property when it comes to JavaScript and CSS, because the browser and the whole world have to see it. But PHP, you might have put a lot of heart into it, and you've put a lot of intellectual property into your PHP code, which is really the secret sauce of your business or whatever. But now the web server needs to be able to read it, as can any customer. So now you're at risk of the customers seeing all the hard work you've done. In fact, what might your files contain out of necessity, if familiar with databases and the like? Yeah?
Well, the PHP would need to contain the name of the database and the password.
Exactly. Things like usernames and passwords for databases, for caching engines, for Facebook APIs, whatever it is, your PHP code might have somewhere inside of it variables that need to be there, but you don't need customer B being able to see it. So in short, running a web server as Apache is great for security of the whole site, bad for the security of customers A and B and C, who probably don't even know each other and certainly shouldn't trust each other. So thankfully, there's a solution here, and it comes in different forms. One of the solutions for PHP is SUPHP. In the SUPHP model, customer A's code is executed by a username called A, the same user's username. B's code is executed by username B. In other words, the web server sort of magically transforms itself into user A when it's time to execute A's code, and transforms itself into user B when it's time to execute B's code. Which means if you screw up and have buggy code and you're customer A, whose files could you possibly delete under this model? Only your own. And that still might be unfortunate, but at least you're not compromising anyone else on the system. And it's your own fault if you delete your own files, but it's a good thing that you can't delete anyone else's files. This also solves another issue. If your website is like a commercial website, even if it's small with only hundreds or thousands of customers, and those customers need to upload files, like photos or videos or stuff that's not meant to be public in the Facebook sense, but fairly private, at least in the limited privacy sense. So the upside here